Look, I'll just quick draw it. I should have drawn it on there. Right, there's a carbon there. You can add this to your prior part, right? So this is our vanilla position. We're gonna make a free radical out of this, okay? 464 kilojoules per mole. Again, it's unstable. Remember the tertiary was 386, so indicating it's more unstable, all right? All right, so for free radicals, we're going to have 6 key arrow pushing patterns, right? 6 arrow pushing patterns. All right. The first one we already talked about, homolytic cleavage. Basically initiated by light or heat. So we have something like this. Say we have 2 radical halogens, all right? You hit it with some heat, that's heat, or H nu, that was for light, right? And you're basically going to have homolytic cleavage. Again, this bond breaks, 1 electron goes to each halogen, and we end up with that, right? That's the first arrow pushing pattern. Number 2, addition to a pi bond. All right? Here we're going to have a free radical, okay? And we're going to add to the free radical, right? Addition, right? Oh, I'm going to make sure I draw this correctly. So what's going to happen here is this 1 electron here and 1 of the electrons from this pi bond are going to come together, okay? And they're going to form a bond between this X halogen, whatever it might be, could be something else, and this carbon, right? So the way they draw this arrow is they have a half arrow here going here, and they have this going here to symbolize making the bond. And then there's another electron here, right? Well, it's going to go there. We're going to end up with this. Okay? Number 3, we're going to have hydrogen abstraction. Okay, which is not the same as a proton transfer. With a proton transfer, the hydrogen goes all by itself. Here, the hydrogen is going to take an electron with it, basically, so to speak. Okay, we have something like this. Again, we have a free radical. Hydrogen connected to a generic carbon chain. And then again, this hydrogen is going to take 1 electron with it, and it's going to form a bond with this free radical electron right there. And we're going to end up with a free radical carbon. Like that. We're going to have halogen abstraction, similar to this. Except we're going to have a halogen. All right? We're going to have something like this. We're going to have a carbon free radical, okay? Then we're going to have our radical. We're just going to form a bond here between the carbon and 1 of the halogens. Again, it takes 1 electron and then this other halogen gets the other electron. And we get a halogen free radical. Sorry, I'm jamming these together is to try to fit this all on the board. Then number 5, we're going to have elimination, okay? Basically like losing a halogen, okay? This is going to be reverse of addition to a pi bond. So we start off with this, okay? Then we end up with that. Again, it's the reverse of addition to a pi bond. And then we got one more. We have coupling, which is the reverse of homolytic cleavage. So here we have 2 free radicals. Again, the opposite of homolytic cleavage, right? So these are basic 6-arrow pushing mechanisms for free radicals, right? I suggest you become very familiar with these. Maybe memorize them or just know them. Right? Just a little bit more about that. Since some of them were the opposite of one another, I'm going to draw those up here, just so you can see this more clearly, okay? So we have homolytic cleavage, right? Each add heat or light, it breaks that bond apart, and we get 2 free radicals. And then the reverse of that was our coupling. So homolytic cleavage. And the reverse of that is the coupling. Right? So those two again were the reverse of one another. Then another one that we had was addition to a pi bond. And we ended up with that, right? Half arrow here, half arrow here, half arrow over to there, right? The opposite of that is elimination, right? Elimination, what happened? Half arrow here, half arrow there, form back your pi bond, get back to free radical, right? And then we have one more. Hydrogen abstraction can be the reverse of itself. You can go back and forth between 2 different chemical species. So here basically what's going to happen, hydrogen abstraction, the proton, again, half arrow here, form a bond between the halogen and the hydrogen, and then half arrow here, forming a carbon free radical. But, oops, hydrogen abstraction. And I forgot to write here, sorry. Forgot to write up here, elimination. Okay, but, and then hydrogen abstraction, we can, abstract the hydrogen the other way onto the carbon atom, would be the reverse of this. All right. So again, 6 basic arrow pushing patterns for free radicals. Here showing you how they're reversible. And that's all I'm going to cover for this lecture. I will send out another one sometime soon. I'm sure you are anxiously waiting.